Welcome back to the course Energy Economics and Policy. During this week and the next week, we are going to cover topics related to energy supply. And specifically, we are going to cover 5 subtopics, namely the investment in energy sector, the economics of fossil fuel, the economics of supply of electricity, the economics of non-renewable as well as the renewable energy. And for this section, that is for energy supply, we are going to heavily rely on the book by Subes Bhattacharya, which is called Energy Economics, Concepts, Issues and Markets and Governments. This was published by Springer in 2011. This is a very good material if you want to know more about economics of energy and the related policies. But before we enter into those 5 topics, our approach will be same as we have done in the case of energy demand. First of all, we are going to explore the concepts and the mechanism of the supply in general. How supply can be conceptualized as an economic concept and what is the theory behind it, how does the supply curve of a producer look like, and so on. It will be interesting if you carry these broad concepts with you as we go on about the detailed topics related to energy supply. So what are we going to look at when we are talking about the basic concepts in economics related to supply? Supply is a decision of the producer, how much the producer is going to supply to the market that can be bought by the consumers. And it basically depends on two things. One is the revenue that the producer is expected to earn by selling those products, goods or services, and the other is the cost of production of that particular amount of goods and services. So it's basically the interaction of revenue and cost that determines the optimum amount a supplier is willing to supply in the market at a particular price. So the objective of the producer is to maximize the profit, which is total revenue minus total cost. Let us have a quick look at the detail of this profit maximizing behavior of a producer and explore how this behavior actually leads to a particular shape of the supply curve of the producer. We'll start the discussion with production function. This is the fundamental concept of the production theory, and the production function actually depicts the relationship between the inputs used and the output produced. So in the functional form, we can write it down as Q is equal to Q of KLEMT. You can incorporate many other variables here where Q stands for the quantity of output produced, and this is a function of K, which is capital. It's a short form of capital. In economics, it's usually K stands for capital and not C, because C we use C for cost. Okay, so coming back to the discussion, K is the capital, L stands for the labor, E is energy, M is material, and T is basically time. You can incorporate many other inputs if you want to, which are contributing to the production of a particular amount of output. So in many cases nowadays you will see that service is being incorporated as one of the inputs in the production function. This T has a very important role to play. See, the functional relationship here is represented by Q. So unlike using a function, say F, in economics the standard way of representing is to use the left-hand side variable to represent the function itself. This is something you have also seen when we were discussing about the consumer's behavior, right? We wrote U equal to U of x1 and x2. So coming back to the role of T, T actually tries to capture the changing relationship between the inputs and output over time. Or in a way you can say T tries to capture the time trend, or T tries to capture the technological progress. So technology in this case is not, you don't have to conceptualize technology in the form of machinery, but technology actually identifies the relationship between input and output. So T captures the technological change as well. However, for the time being, we are going to keep this T aside and we'll deal with only the inputs. So when I write down all the inputs, capital, labor, energy, material, all of them, they are not similar. I mean, their nature are not similar. How are they different? Let us have a quick look. If you think in a short run, suppose for 2 years, 3 years, once you make some investment in order to produce some goods and services, this investment will cater to the entire time period for the time period for which the production will go on for a longer period of time. So capital, your investment in capital, the amount of money that you are spending, for example, to come up with the complex, to buy the land in order to set up all the machinery, this is called capital, and this is sort of an proxy for the investment, right? So the capital comes as a form of investment, and in the short run you can assume that your capital is fixed. So the amount of investment that you have made at the beginning of the production process is going to actually help the production for a particular range of years. So therefore, capital in the short run can be considered as a fixed input. On the other hand, if you look at labor, energy and material, we can consider them as the variable inputs. So as the production, we want to increase the production, we have to increase the quantity of these variable inputs. Now, let us go back to the example that we have been considering in the previous week in the context of load management. We have been continuously saying that it's very, very important to flatten the load curve. Why? If you can reduce the gap between the peak demand and off-peak demand, then the capacity of power generation that you need is going to be reduced. So among different competing investment, you don't have to put your money in a particular place where there is unproductive where there is no productivity for a particular duration of time. So investment is something, or the fixed input is something that is once spent, it stays there. It does not change with the change in the level of output. So fixed input is the fixed at the beginning of the time period. Whereas if you think about coal or gas, so the quantity of coal or gas would actually keep on changing as you change the quantity of power produced. So that is what we again said, that during the off peak period, even if you shut down a few units in the power plant, that will actually save your cost on the fuel. So the coal, the expenditure on coal will be saved. However, the expenditure that you have already made in order to come up with the power plant, that is going to stay with you. So the concept of this variable input and the fixed input is very, very important whenever you are thinking about any production process in the short run. There are two related concepts that we are going to discuss. The first one is the average productivity of variable input. So what is that? If you think of energy as the variable input, then total output Q divided by total energy used, E, is called the average productivity of the variable input. Here again, let me remind you that if you take the reciprocal of this average productivity, that is, if you take E divided by Q, you actually go back to the concept of energy intensity that we had been discussing during the first week of the lecture. There is another concept related to the productivity of the variable input, that is the marginal productivity. The marginal productivity is actually defined as the increment in the quantity of output as you increase the quantity of input at a margin, right? So this is incremental change in energy input. What is the result on the change in output? So this is the marginal productivity of variable input. Later you will see that marginal productivity of variable input and average productivity of variable input is actually closely associated with the concept of average variable cost and the marginal cost, which is marginal variable cost again. Once we start with the production function, next we move on to the concept on cost function. So what is cost function? Cost function depicts the relationship between the level of production and the cost of production. So one note I would like to make here, that oftentimes we confuse between the cost function and the isocost line. So cost function is typically depicting the relationship between the level of output, that is Q, and the cost that you incur in order to produce that level of output. So no input is taken into account here. So Q, in a sense, you can say that this total cost is indirectly a function of the level of input, because your Q becomes a function of level of input, but directly the total cost is basically a function of the quantity produced. Okay, so in case of isocost line, what we did, in case of isocost lines, we actually talked about the relationship between the inputs used and output produced. So it's the cost of input and the total cost. Here we are relating the concept of total cost with the level of output which is being produced. So this is one thing you have to be a little careful about. The way we discussed about the fixed input and variable input, the analogy is here fixed cost and variable cost. You take the example of the machinery that you have to put in place in order to set up the power plant. So that was the capital investment and that was a fixed input. Here the money that you spent in order to fix that, in order to set up that machinery is called the fixed cost. So this is the part of cost which does not change with the level of change in output. So it doesn't matter whether you are producing electricity during the peak period, that is high volume of electricity, or you are producing electricity during the off-peak period where the production is low, your fixed cost is going to remain unchanged. Analogous to the concept of variable input comes the concept of variable cost. So this is again, as we discussed, during the off-peak period, some of your units are shut down and therefore you are not producing as much electricity that you have been producing during the peak period, and therefore your cost on variable input, for example fuel, is going to come down. You can also think about in this way, you need less manpower, you need less material to produce less amount of output. So we can see that the fixed cost does not vary with the level of output, whereas the variable cost actually varies with the level of output. So as the level of output increases, the variable cost also increases. Now we are going to take you through a couple of relationships regarding the costs, and these are very simple but just some fundamental idea about the cost functions. So total cost, that is represented here as a cost as a function of Q. Total cost can be divided into two parts, total fixed cost and the total variable cost. The average fixed cost similarly can be represented as total fixed cost divided by Q. The average variable cost is represented by total variable cost divided by the level of output, that is Q. The average cost, which takes into account both types of cost, is the sum of average fixed cost and average variable cost, or you can also write it in a way total cost divided by Q, which is total fixed cost plus total variable cost divided by Q. The next concept is called the marginal cost. Here we are deviating from the concept of average, and this is the change in cost due to change in output. So the question that we try to address here, if I want to increase my output by 1 unit, what will be the impact on my cost? How is my cost going to increase? Now here you can see that what I have written, that marginal cost is not only equal to delta total cost by delta Q, it's also equal to delta total variable cost divided by delta Q. The reason is that when you are talking about marginal cost, you are only talking about that part of the cost which will change as you change the level of output, and that is your total variable cost. Total fixed cost has no role to play in determination of marginal cost. In fact, it's not a part of the marginal cost at all. Let us have a quick numerical understanding of what all these concepts mean. So these are some imaginary numbers here which are measured in some suitable units, but this is just, I have been come up with these numbers just to give an idea. This is not from any real example, but just sort of an illustration. So in the first column, what we have the amount of fixed input. So this is the capital that is there, which is going to stay during the lifetime of the project or a particular duration of the lifetime of project. And this is something which is not, this is a one-time investment and not going to change with the change in the level of output. So there are 6 units of capital. You can think about it as 6 machines or 6 units of power production or whatever you want. And we are assuming that the total fixed cost that has occurred due to the 6 units of fixed input is 10,000. You can think about rupees or lakhs or crores of rupees. So for 6 units, the spending is 10,000. Now see, there are multiple entries of 6 and multiple entries of 10,000. So when I put the value of variable, put the value of output, you will see that the objective of doing this is to show that with the change of output, there is no change in the variable input. I'm sorry, there is no change in the fixed input. Next, we are inserting the variable input. So, along with 6 units of fixed input, we are putting 1 unit of variable input, and at every stage, we just go on adding up 1 extra variable input, and we will see what is going to be the total variable cost. So you see that there is a simplified assumption where we have assumed that each incremental unit of energy, that is the variable input, will cost 5,000 rupees. So when you are putting 1 unit of variable input, that is 1 unit of energy in your production process, your total variable cost is 5,000. When you are putting 2 units of energy in your production process, your expenditure, that is total variable cost, is going to be 10,000. Similarly, when you are putting 9 units of energy, your total variable cost is going to be 9 multiplied by 5,000, which is 45,000 rupees. Now let us see what is going to be the impact on output. So it grows like this. So while keeping the capital constant, as we are increasing the fuel or increasing the energy input, our output is actually increasing. So for the first unit of variable input, we are producing 65 units of output. It just increases as we go on adding more fuel in the production process, and 9 units of variable input along with 6 unit of fixed input is producing 882 units of output. Now you can also relate to the fact that this varied level of output, that is this increase in output, is associated with some total fixed cost and some increasing total variable cost. Now if that is the case, let us first have a look at the average productivity of the variable input here, which is energy or fuel. So the average productivity of variable input, you may recall, is calculated by dividing the total output by the units of variable input. So the 65 is basically 65 divided by 1. When you have 110 here as average productivity, this is basically 550 divided by 5. When you have 98 here, you actually have 882 divided by 9. So you see what is happening to average productivity. Initially, the average productivity is increasing up to this point, from 65 to 113, your average productivity has increased. After that, the average productivity is declining. We'll quickly come to the explanation of this kind of a behavior of average productivity when we pay more attention to the shape of the curve. The next concept that we are going to look at is the marginal productivity of energy input or any variable input per se. You can also think about the average productivity and marginal productivity of labor. So what is happening here? Let us first focus on this column, that is delta E. You can see that here, in case of variable input, that is for the second column for E, at every stage we are adding 1 unit of energy as the variable input. Therefore, delta E at every stage is equal to 1. What is the delta Q? Delta Q is the change in output due to 1 unit addition of variable input. So this 95 comes as a result of 160 minus 65. If you look at this 128 here, this is a result of 678 minus 550. If you look at 42 here, this is nothing but 882 minus 840. So if you look at the marginal productivity, if you want to calculate the marginal productivity, this is basically delta Q by delta E, and this is actually a special case because delta E is equal to 1 everywhere. Here you can see that delta Q and the marginal productivity of labor are different. However, you can make some variation in order to have a better understanding. What you can do at every stage, instead of adding 1 unit of variable input, you can add multiple units of variable input and you can vary it from stage to stage, and then you can see what is going to be the impact on marginal productivity of energy, which is a variable input. So we started our discussion with the production function. So this relationship, all these relationships which are represented by this Q, Q, K, E, the behavior of the average productivity curve, the behavior of the marginal productivity curve, All of them together, they actually determine the shape of the production function. This is where we began. The next discussion was on cost. So let us see what are the implications on cost with this kind of numbers. We already have the information on total fixed cost and total variable cost. We'll add them up in order to come up with the figure for total cost. So total cost is nothing but the addition of total fixed cost and total variable cost. The next concept that we are going to come to is the average fixed cost. We are getting the average fixed cost by dividing the total fixed cost by the units of production. So 153.8, this value for average fixed cost is actually 1000 divided by 65. When you see 11 and 11.3, this is nothing but this 10,000 divided by 882. So if you look at the shape of the average cost curve, average fixed cost curve, you will see that the value of average fixed cost is continuously falling as the production is increasing. This is very, it's quite obvious because 10,000 is being divided among more number of units of output that you are producing now. If you also pay a little more attention, you will see that if you multiply the average fixed cost by Q, so if you multiply by average fixed cost by Q, you get total fixed cost, which is constant. So if you want to draw the the shape of the average fixed cost in the cost quantity plane, then you should get the shape of a rectangular hyperbola. We next move on to the concept of average variable cost. Similar to average fixed cost, here we are just dividing the total variable cost by the quantity of output. So if you look at this number 76.9, this is we are getting by dividing 5000, that is total variable cost, by the total output 65. If you look at the last entry, that is 51 as the average variable cost, here we are dividing this 45,000 by 882. So when we look at the average cost, this is nothing but the summation of average fixed cost and average variable cost. So 230 comes as a result of addition of 153.8 and 76.9. Similarly for the rest of the entries. The next one is the change in cost. Next one we are interested in the marginal cost. So what is marginal cost? Marginal cost is basically the change in cost due to 1 unit change in output. So delta C by delta Q. See, delta Q we already have calculated here. Now what we are going to do is to calculate delta C. So when we say delta C, you see this is always 5000. So as I have mentioned before, that delta C is basically equal to delta average variable cost, because that is the only component of cost which is actually changing your total cost as your level of output is changing. So delta C here is 5000 at every stage. So to get this number 52.6, what we have to do, we have to divide this number 5000 by the number 95. Similarly, if you come to the last entry 119 as the marginal cost, this is a division of 5000 by the number 42. So this is how you get a complete understanding of different concepts related to production function and related to cost function. Next, we are going to look at the shape of this relationship, shape that can actually capture these relationships. Let us dive with the production function. So as we have said, if I plot these numbers, the 65, 160 and up to 882 on the vertical axis, and on the horizontal axis I have the variable input. So I am varying the variable input from 1 to 10. For 10 I don't have an entry. This is basically, it should be up to 9. What we are getting is that different levels of output. Once I plot this curve, I get the shape like this. So one thing that you can observe is that the K, that is capital, is the fixed input that we are considering, and energy is the variable input that we are considering. So you can see as the variable input increases, the amount of production also increases. But up to a point, it increases at an increasing rate and then it increases at a declining rate. So theoretically, the production function is basically an upward rising function of the variable input where the first order derivative is positive and the second order derivative is negative. Next, we look at the marginal productivity of the variable input holding the fixed input, that is K, constant. And marginal productivity, if you can recall, is nothing but Q by E. So this is the type, this is the shape that we are getting. If you look at this blue line here, this is, here you have average productivity of labor, and if you look at the orange line here, this is depicting the marginal productivity of labor. So you can see initially the average productivity of labor was lower than the marginal productivity of labor, but marginal productivity of labor cuts the average productivity of labor, or sorry, here we are considering energy. You can actually think about any variable input from up, and then it becomes less than the average productivity of energy. So this is the relationship between the average productivity of variable input and the marginal productivity of a variable input. These concepts become very handy if you go into the rigorous discussion and calculation of the cost structure while setting up some kind of energy supply system. The next one, which is very important, is the shape of the cost curves. You can see this blue line is the average fixed cost, and as we have said, this resembles a rectangular hyperbola because here we are plotting the output and here we are plotting the cost. So it's sort of a rectangular hyperbola. The next one is the average variable cost. So this orange line gives you the average variable cost. Theoretically, this is, although you see it's like a valley, but it basically, theoretically, we think that it takes the shape of a U curve. So initially it declines, it reaches a minimum and then it starts increasing. In case of average fixed cost, this is a combination of the average, in case of the average cost, that is in a totality about average cost, this is a combination of average fixed cost and the average variable cost. So initially the average cost declines, however after a point it starts increasing. Let us spend a little amount of time in order to understand the shape of these curves. So what is happening? Here if you look at the blue line, 10,000 is being distributed to more number of outputs, more units of output, and therefore this blue line representing the average fixed cost keeps on falling. However, if you think about the average variable cost, what is happening? This is total variable cost, right, divided by the units of production. So initially, as you have some fixed input which is capable of producing a certain amount of goods or services, and you keep on adding more variable input, then your fixed input is actually performing in a better manner. So your average cost is declining. If I go back to this diagram, here also you will see the average productivity of energy service is initially increasing, then it starts declining. So think about this power plant which is being set up to produce probably some, maybe 3000 megawatt of power, and initially you are producing only 30 megawatt. So as you keep on producing more power, your productivity of energy input is going, but beyond that there will be over exploitation of your capital, and therefore the productivity of energy will decline. So coming back to the discussion of the cost curves, the same thing is represented here. So if you look at the average cost curve, or if you look at the average variable cost curve, initially they are declining because your variable input is becoming more and more efficient. After that, there will be an over exploitation of your fixed input, and that makes your variable input less productive, and as a result, your average cost and average variable cost keeps on increasing. So both average cost and average variable costs are actually U-shaped. Now we add the marginal cost curve in the picture. So this sharp blue line, this is the marginal cost curve. So marginal cost curve theoretically is also U-shaped. It starts from the below of the average fixed cost, average variable cost and average cost. However, cuts both the curve respectively from below, and then eventually it becomes higher than the average cost and average fixed cost. Now here it's worth having a quick discussion on two concepts called break-even point and the shutdown point. At this point, it's actually worth discussing two very important concepts. One is the break-even point and the other is the shutdown point. So break-even point is the minimum point of the average cost curve. The average cost curve being, U-shaped, that's the minimum point of the average cost curve, and this is the point where the marginal cost curve actually cuts the average cost curve from below. So what happens at this sort of minimum point of average cost curve? So this is the point. If you produce here, and if the price that you fetch is here, this is the price that you are getting from the market, then the revenue that you earn will be exactly same as the total cost of your production, including the fixed cost as well as the variable cost. So if you produce here and the price that you get is also here, then your total revenue will be equal to total cost. So you are breaking even. So there is no emphasis either on, sort of your, there is no emphasis on your cost or no emphasis on your revenue. Both are equalized. So this is called the break-even point. Now one may surprise that if the total revenue is equal to total cost, then where does the profit come from? So when the cost is calculated, the cost to entrepreneur is also included in that total cost. So that is the profit which is going to the entrepreneur, which is already included in the total cost, and when that is there, it's called a normal profit. So try to remember this point, that at the minimum point of average cost curve, it's called a break-even point, and a company breaks even at this point because the total revenue and total cost are equal. However, if in the short run your production is such that the price falls a little below the average cost curve, then it can survive, because it feels that if it can pay the variable inputs, then it can survive in the long run. It can make up for the fixed input for certain period of time. However, if you come to the minimum point of the average variable cost, this is called a shutdown point. Why? Because at the minimum point of the average variable cost, if you sell at this point, then the total revenue that you earn is actually equal to the total variable cost. So if your revenue goes down below the total variable cost, you actually cannot provide fuel to the power supply sector in order to produce electricity, and you have to shut down your plant. You can delay the interest payment on capital a bit, but you cannot have a delay with regard to the payment to the fuel. So this is called the shutdown point, because if your point of operation is below the minimum point of average variable cost, then that is not feasible and you have to shut it down. Next, we try to explore how the supply decision is made by a producer, especially in the short run. So what is the difference between the short run and long run? It's basically, in the short run, the capital is considered to be constant, whereas in the long run, the capital will also be considered to be a variable input. So what happens in the short run? The short run, the profit of the farm is given by given by pi, which is P multiplied by Q. That is the total revenue of the farm. P is the price of the particular good or service that the farm is producing, and Q is the quantity. You can think about electricity. So P is the wholesale price of electricity, and Q is the amount or units of electricity produced by the power plant, minus CQ. CQ is the cost of producing the electricity. So what does the farm want? The farm's objective is to maximize the profit, that is to maximize pi with respect to, and what is the decision variable? The decision variable is Q. So the farm is actually going to choose a particular quantity which maximizes the profit of the farm. So the first order condition is given by del pi del Q is equal to 0, which takes you to the scene where P minus MC is equal to 0, or you can say P is equal to MC. So the price has to be equal to marginal cost. Now when we talk about price, one quick thing to note about this is that the price is not something that the supplier can influence. That is the assumption here. So this kind of a situation happens when you are more in a competitive structure and the quantity that you are producing is only a small fraction of total quantity of that particular item supplied in the market. So here you see P is given by outside, and this is actually it's sort of exogenous for the producer. So that in the decision making, the first order condition gives you the result P is equal to MC. The second order condition says that del 2 pi del Q2 has to be negative because you are maximizing the profit. If that is negative, then your marginal cost should be rising, because if you take the second derivative here, the del MC del Q comes with a negative sign. So your and minus del MC del Q, that has to be negative, which means that del MC del Q, this has to be positive. So your marginal cost has to be rising at the point of supply. So the profit maximization happens where P is equal to MC is equal to marginal revenue, which is MR. Now if P multiplied by Q is your total revenue and you define your marginal revenue as delta total revenue by delta Q, then P becomes your marginal revenue. So this is the profit maximizing condition for the producer. Now let us have a quick look at the diagram. So in the horizontal axis we are plotting, this is actually the quantity produced, and on the vertical axis we are plotting both price as well as cost. How does the cost curves look like? So this is the average fixed cost taking the shape of a rectangular hyperbola. Then you have the average variable cost. This is a U-shaped curve. Then you have the average cost, which is a combination of average fixed cost and average variable cost, or more precisely, this is the vertical sum of average fixed cost and average variable cost. And then we are plotting the marginal cost curve, which is also U-shaped, but it starts from here and then goes up, cuts both average variable cost as well as average cost from below, and then it goes up. Now let us see what is the profit maximizing condition for the farm. It says P has to be equal to MC. We'll come to this point in a while, but let us have a quick look at the second order condition first, which says that it has to be the rising part of MC. So we cannot have any profit maximizing equilibrium at the downward falling part of MC. When we are talking about the supply curve, it has to be the upward rising part of MC. However, as we have come to know that the minimum point of average variable cost is actually a shutdown point, no production and supply can take place below this shutdown point. And therefore, the supply curve is actually that portion of rising marginal cost curve which is over and above the average variable cost. So remember this, for all kind of competitive equilibrium, the supply curve in the market is basically the upward rising part of marginal cost curve over and above the average variable cost. Now let us pay a little bit of attention to what this P equal to MC says. So it says that if P is equal to 20, that is the market price is 20, again recall this market price is exogenous to the producer and the producer cannot influence this P. So the producer kind of takes P as sort of given, right? So but the decision that the producer is going to take is that if P is equal to 20, what is going to be the quantity that it should produce and supply in the market. So here we see if P equal to 20, the P equal to MC is taking at the point where this horizontal line stating P equal to 20 intersects with the marginal cost curve. That is the point, this one, where the pointer is. If this is your equilibrium, then what is the quantity produced by the producer? The producer is producing some quantity, for example, Q equal to 50 and supplies in the market. However, if the price falls from 20 to 16, that is there is a decline in the market price, then you can see that the equilibrium of this producer is actually shifting from this point to a lower point of the marginal cost curve. That is, it comes here. And at this point, so at price equal to 16, the quantity supplied by the producer in the market will be less than 50, and let us assume it is 45. So what is a supply curve? As the demand curve was actually depicting the relationship between the price and quantity demanded by a consumer, the supply curve is actually depicting the relationship between the price and quantity produced and supplied by the producer in the market. And this kind of a structure is prevalent in the context of a competitive framework. If you go to a monopolistic framework, the structure can change. There's a lot of change in the structure, I must say. But here we are dealing with only sort of a competitive framework. So here we can see that as the price increases, then the quantity produced and supplied by the supplier also increases. So the supply curve, that is why, actually gives you an upward rising curve when plotted in the plane with quantity supplied and the price. However, one more point of caution: when I'm saying that this is a shutdown point, that is the minimum value of average variable cost, and the supply curve should lie over and above the average variable cost, my understanding is that we are talking about the short run. Right? In the long run, as you now know, that none of the variables remain fixed and everything becomes, none of the inputs remain fixed and everything becomes a variable input. The last thing that we are going to look at is the shape of the industry supply curve. So again, if we go back to the example of power plant, there are various power plants who are producing the power and supplying to the grid. So there is NTPC, there is Tata Power, there are a lot many of them. So how the production, or how the supply, the total supply is actually being distributed in among the different producers, or how the production of different producers actually determine the total supply in the market. Let us take three panels. In the first panel, I am going to show the supply curve of the first plant producing electricity. In the second box, we are going to talk about the second plant, the cost curves of the supply curve of the second plant, and in the third panel, we are going to show what is happening in the market. And here, this horizontal axis is actually representing the total output which is being produced. So if we start with this, suppose this is the supply function of the first plant. So this is the marginal cost, the upward rising part of marginal cost for the first farm over and above the average variable cost. The next supply curve looks like this. So you can see that although they are producing the same thing, the supply curves may vary. So in case of this particular farm, in order to increase 1 unit of production, the increase in cost is much higher as compared to plant 2. So the marginal cost, the slope of the marginal cost for plant 1 is actually steeper as compared to plant 2. Now what do we do? Suppose the price is fixed at this. So price equal to 20. This is the market determined price, and both plant 1 and plant 2, they are taking this market determined price as an exogenous information. Now what do they do? The first plant, given their profit maximizing behavior, will supply at this point where P intersects the marginal cost curve, and the quantity supplied here is Q1. For the second plant, when P is equal to 20, given the profit maximization behavior, this plant is going to supply this much, Q2. So when P equal to 20, the total supply in the market is going to be equal to Q1, this one, and Q2. So this is Q1 and Q2. So if you think about the industry supply curve, you will see that at price P equal to 20, total output supplied will be equal to Q1 plus Q2, and this is how the industry supply curve looks like. So the slope of the industry supply curve, or you can say that the absolute slope of the industry supply curve is less than the slope, or the absolute slope of the the supply curve of each and individual plants. If you keep on adding more and more plants in the system, after a point of time, you will see that the industry supply curve will become actually horizontal. So any amount of quantity can be supplied at a particular price by the industry. But again, to make a note, this is the structure which is prevalent in a competitive market. In monopoly, things are very different. So what we see here, you see that industry supply curve is a sum of firms' supply curves over quantity. So not over price, but over quantity. The second thing that I would like you to notice, it also talks about the distribution. So if the total quantity that you want to produce is Q1 plus Q2, how do you distribute this entire quantity among the two plants given a particular price? So what you actually do is that if you ask the plant with lower cost to produce more and you ask the plant with higher cost to produce less. If you see here, we have already discussed that for plant 1, the absolute slope of this marginal, the slope of this marginal cost is actually, you see it's steeper, right? So it has a higher slope. As compared to this, it has a lower slope. So if your marginal cost curve is flatter, that means to produce one additional unit of output, you need less amount of extra cost. So this is the more efficient plant in from the perspective of the marginal cost. And if you see here Q1 and Q2, actually Q2 is higher than Q1. So the plant with a lower marginal cost is contributing more to the market supply as compared to the plant with higher marginal cost. And we will come back to this concept again when we discuss about the supply of electricity. So this is the decision that the electricity supply, power supply sector has to take into consideration which unit is to keep shut for a particular point of day. Okay. So we are going to come back to all of the concepts as we go through the different areas of and cover different areas of energy supply. This week for the first lecture, we are going to stop here. In the next lecture, I'm going to meet you with more topics related to energy supply. Thank you.